Let's find the instantaneous rate of change at 2 for this given function. Let's first recall the IROC formula. Our x value for this problem is 2. So the 2 is going to replace the x for this. So let's do that real quick. Now let's plug this 2 plus h and 2 into the given function. So what I'm going to have here is the limit as h approaches 0 of, now the function f, we're going to plug in 2 plus h first. So I have 3 times the quantity 2 plus h squared plus 5 times the quantity 2 plus h. And we are going to subtract when I have a 2 plugged into this function. So 3 times the quantity 2 squared plus 5 times 2. And this is all over h. Now this becomes a simplification problem. One thing I want to point out first though is that you are subtracting 2 into this entire function, so it's really important that you include this set of parentheses right here because you want to subtract that entire function with a 2 plugged into it. Let's do some simplification using the order of operation. So I have 3. Remember that 2 plus h quantity squared is 2 plus h times 2 plus h. So I'm just going to expand that out. Plus, I'm going to multiply this. 5 times 2 is 10, and 5 times h is 5h. And let's do some simplification inside the parenthesis. 3 times 2 squared. Well, 2 squared is 4, and 4 times 3 is 12. And 5 times 2 is 10. And this is all over h. So I can multiply this out. So I have 3. 2 times 2 is 4. 2 times h is 2h. H times 2 is 2h. And h times h is h squared. And then I have that plus 10 plus 5h minus, do the parentheses, I have 22 all over h again. All right, almost done with the algebra here. I'm going to combine like terms first. So I have 3, and then inside the parentheses I have 4. 2h and 2h can be combined to 4h. Plus, I still have this 10 plus 5h. And now I could just say minus 22 all over h. The last set of parentheses I need to get rid of is this one. So I need to do 3 times 4, which is 12. 3 times 4h, which is 12h. 3 times h squared, which is 3h squared. And I'm just going to write what I have here because nothing has changed. Now I'm going to combine some like terms. So I'm going to order things with the h squared term first. So I have 3h squared. I have 12h plus 5h, which is 17h. And then I have 12 plus 10, which is 22, minus 22. So there is no constant term. So this is all over h. Now, if I evaluate the limit where h is 0 now, I get 0 in the denominator, which is undefined, and I don't want that. So what I need to do is I need to factor out an h from the top so I can make a big fancy one. So let's pull out an h. So I have h times the quantity 3h plus 17 all over h. Make a 1 through that. And now all I need to do is I need to plug 0 in for this h right here. So I have 3 times 0 plus 17. Well, 3 times 0 is 0, plus 17 is 17. So the instantaneous rate of change for this problem is 17. Remember what this means. This 17 is the slope of the function where x is equal to 2. Now we are on to the second part of this problem. So recall, in the last problem, we found the instantaneous rate of change at x equals 2 for this parabola. We found that the slope is 17. 17 is the slope of the tangent line. So the second part, we want to write the equation for the tangent line at x equals 2, where we know the slope of that line is 17. I always like to use graphing form of a line to help write the tangent line. Let's recall what that is. That's y equals our slope m times the quantity x minus h plus k, where our h and k value are any point on the line. How do we find hk, the point on the line? Well, we know that the x value is 2, so to get the corresponding output value, I'm going to plug 2 into the function. So I have f of 2 equals 3 times 2 squared plus 5 times 2. 2 squared is 4 times 3 is 12, plus 5 is 10, 12 plus 10 is 22. So hk is 22. So to get the equation for the tangent line, we'll need our 17, our slope, and any point on the line for hk. In this case, we want to use 2 for x because that's what it asked us to do, and we needed to get the corresponding y value. So we get y equals 17 times x minus 2 plus 22. This right here is the equation for the tangent line.